Video Lecture 5.5, the Tropical Subtropical Desert. Of all the climate regions we'll be looking at, this is going to be one of the driest, but also the hottest place that we'll look at. Here, key to understanding it is that it has permanent moisture deficits, which is a fancy way to say that there's always a drought here. Understanding the reasons for that, key is subtropical high pressure that dominates and pretty much sits here the entire year. Also, you'll find these in warm weather tropical areas that have mountainous areas with those rain shadows, and so rain shadow effects. And so you'll see this in Caribbean and parts of Africa and Asia as well. Where would we find the tropical, subtropical deserts? We find, of course, the Sahara, the Middle East, Baghdad for those veterans, Kalahari for those veterans, and then, of course, Arizona in the American Southwest. So in sum, they cover about 1/3 of Earth's surface is a tropical or subtropical desert. Once again, we go to our good friend Hadley Selford. Understanding the reasons for it being quite dry is the fact that these air parcels essentially have removed most of its moisture by the time that it descends, and of course when it's descending at 30 degrees north, we know high pressure, we know descending air we associate with dry air. Here we have a climate graph comparing a tropical rainforest with tropical desert. One of the things you'll note is the temperature actually during that period when the subsolar point is closest to our location here in the tropical desert, actually the temperature is much higher than what you'd find in the tropical rainforest, and that once again goes to the whole idea of lack of cloud cover. But when the subsolar point's in the opposite hemisphere, it's actually quite far compared to tropical rainforest. That's why we see that dipping down quite low compared to the very horizontally linear purple line on the left. Of course, you'll notice the precipitation differences, which is quite obvious with that dominance of a high pressure compared to the equatorial low pressure trough that dominates the tropical rainforest. We can visibly see this with the Sahara in the Middle East, but much of the areas that are 30 degrees north, roughly, and 30 degrees south, we can see the brown illustrating the sparse vegetation due to the arid climates. Here we have Saudi Arabia and the star, which is going to be shown on the following image. Right here, illustrating the lack of vegetation, the minimal vegetation, which is clear evidence that this place gets minimal precipitation. Here we have the aloe plant. If you notice its color, it's light in color, and that goes back to the idea of albedo. And so its competitive advantage is that it has a light color. So we think about subtropical high pressure, you're going to have sun pretty much all the time. And so how does this plant compete against others? Well, it just uses a lighter color. Here we have some desert plants, and what happens with desert plants is they have the roots are very, very close to the surface. So anytime there's moisture, they go nuts. And also when there's moisture, that's when they do a lot of times their seed germination. So whenever that little bit of rain happens, the place just goes nuts with all this activity, but it's very, very short-lived. Here we have a tree that is a real tree, and it looks like a bottle and very much functions like a bottle. And so what it does is it stores water during that, the much of the dry period that exists throughout the year. And so it's competitive advantage. Just anytime it gets water, it's just going to store it. Of all living things on Earth, this is one of my favorite. This is a bristlecone pine, and so this is a tree that could live up to 5,000 years. They know it because if they core it, they can see, because of tree rings, they can count the rings, and then they can figure out how old this sucker is. But these are things that are literally anywhere from 2,000, 3,000 to 5,000 years old, which is amazing because what they essentially have done is they live in a very dry area, and so they've over time been able to just deal with not having much. So they're very hardy, and they really don't require that much precipitation. But when they do, they take advantage of it, of course, and helps it to survive. What's interesting is when we think about weather, we only know about 100 years worth of weather. But using bristlecone pines, we can actually use tree rings, which the wider the ring means the wetter the season, the thinner the ring means the drier the season, can go back and deduce nearly 5,000 years of precipitation data for this area, which is fascinating with stuff that's being done by Tennessee geographers. Here you see people from North Africa, and they're wearing a lot of clothing. You're wondering why. This is a very hot area. However, at night, when the sun goes down, there's no clouds to delay and to help keep in the heat, and so it gets quite cool. And so over time, they wear a lot of clothing. They also wear a lot of clothing because it helps to block the sun from their skin during the all-day long period as they're migrating from place to place.